Do you want to build an AI chatbot for your business? A chatbot that helps the customers to understand about the services and offerings that your company provides. Whether you run a software company, restaurant, real estate agency, travel agency, or any other business, a well-designed chatbot can serve as a virtual assistant to engage customers, providing right information. So in today's video, we are going to build an AI chatbot which is a RAG-based chatbot that can answer users' questions based on your PDF documents. You only need to upload your business PDFs and the chatbot can answer all of your users' questions. So you can upload your PDFs that contains the business information and the AI chatbot do the rest of the things. In this app, you don't need to use any API keys. Everything can run locally. So let me show the demo first. For this demo, I created a few dummy PDF content about a hospital named City Care Wellness Hospital. So these PDFs contains the general information, appointment details, details about the doctors and other information in different categories. I have already uploaded these PDFs and created the vector index. I will show you how to upload the PDFs and working of the system later in the video. Now we can check this chatbot with a few questions. In this UI, you can see a drop-down list here. User can choose any one of these options from the list. This option is to identify in which category that user's questions belongs to. For example, if I want to know about appointments, I need to select that category and ask questions. Or if you want to know about available doctors, I need to select that option and ask questions. First, we can ask questions that is related to appointments. So my question is how to make online appointments. The model is thinking. The response time will be depends on your machine hardware because we are running a model with 1.5 billion parameters. As you can see the result from the model, it gives a detailed explanation of how to make online appointment in step by step. Now we can ask a different question that relates to doctor's list and appointment. For that, I am selecting this doctor's category and I am asking the list of the doctors and their appointment timing. It also gives a well-detailed answer who were the doctors and their appointment details, department, etc. Let's try with another question. Who is the pediatrician and what are their working hours? This time it also gives the correct answer based on the PDF. If you compare the details with the actual PDF, you will know that it gives the correct answer. Now check with a different question. What are the insurance available in this hospital? This time also it gives a well-structured answer where it explains the details of the insurance that is available in this hospital. This way you can upload your own PDFs in different categories and create your own business chatbot. To build this app, I use Streamlit, Python and the model DeepSeek. Here is the architecture of this app. PDFs that contains the business information will be uploaded in the directory PDF uploads in different categories. Once the PDFs were uploaded, we can build corresponding vector indexes by running this command. This Python script will create the vector indexes for the corresponding PDFs and it will be saved in the directory vector data in different categories. For building the vector indexes, we use the model All-Mini LM L6v2. When the user asks a question, that content will also be converted to vector form and use this vector to search similar content in the saved vector data. Then it retrieves the similar content from the saved vector data and passes that data to the LLM, which is DeepSeek. Basically, Here we pass the user's question plus the retrieved content with a customized prompt to the DeepSeek model. Here the DeepSeek model is running using Ollama. You can use different model like Mistral, Llama and other models if you want to. So once the DeepSeek model gets the prompt, it processes the prompt with the vector data and gives a structured output to the user. So here we are passing user's questions plus its answer to the model, and the model structured it and give it back to the user. So that's the overall architecture of this app. Now we can set up this app. Before starting to build the app, make sure you have installed Ollama in your system. Ollama is a free open source tool to manage and run LLMs locally. If you are not installed, download and install from their official website and then pull the model DeepSeek. I am using DeepSeek R1 1.5b. Once you pull the model, make sure it is up and running. So these are the libraries that we are going to use in this app. FAISS, Facebook AI Similarity Search, is used for efficient similarity search and vector storage. It stores document embedding in a vector index, enables fast retrieval of the most relevant documents for a given query. This is critical for semantic search in our chatbot. Streamlit. Streamlit is a Python web app framework for building interactive data-driven UIs. We use Streamlit to create the chatbot's frontend. Ollama. Ollama is a local LLM runner that allows you to run models like DeepSeek or Llama on your machine. Sentence transformers. This library for state-of-the-art embeddings using the transformer models. It converts both queries and documents into dense vector embedding for semantic search. Ensures FAISS can find relevant chunks based on meaning, not just keywords. Now we can set up the project. Create a new project directory and set up the virtual environment and then install these libraries. You can use this command to install these libraries. Also, you have to create two directories under your main project directory, which are uploaded PDFs and vector data. The folder uploaded PDFs is used to upload the original PDFs, and the directory vector data is used to save the vector indexes. So you should create these directories. We need to save the vector indexes using the uploaded PDFs. For that, I created a file called savedata.py. In this script, we will convert the uploaded PDFs to vector indexes for similarity search. Basically, it reads all the files from the uploaded PDF directory and creates vector indexes and saves inside the vector data directory, which later used for similarity search in the RAG. I will go through the main methods in this file. Load all PDFs. It reads all PDF files from a given folder and loads their content into memory. It looks all the files in the provided directory. If a file ends with PDF, it uses PyPDF loader from LangChain to load it. Each PDF is split into document objects, one per page. Split documents. It breaks each document into smaller text chunks for better embedding search accuracy. It uses recursive character text splitter from LangChain. Each chunk up to 1000 characters with a 200 character overlap to keep the context. It returns a list of small document chunks ready for embedding. LLM embedding work better on smaller context-focused text chunks instead of huge paragraph of pages. Create vector index. It turns your text chunks into vector embedding and stores them in a FAISS index. It extracts text from split docs, then uses sentence transformer to convert text into embedding, then creates a FAISS index to store these vectors, then adds embeddings to the FAISS index. Finally, it returns both the FAISS index and the original chunk text. FAISS lets you quickly search for similar text chunks using vector similarity. Save index saves both the FAISS index and the text metadata to disk. It uses FAISS write index, saves the actual vector index, then pickle dump saves the original text chunks so you can retrieve text after finding matches. Without saving, you have to recreate the index every time. While you upload the PDFs, you can create separate folders under PDF uploads for each category. For example, general, appointments, doctors, etc. And you can upload corresponding PDFs under each category. This will help to list the tags in the UI, and also we can easily retrieve content based on the category. Now we need a UI to interact with the LLM with RAG. For that, I'm using Streamlit. Now I create a file called app.py and write the script for the UI. I will go through the main methods in this script. You can find the full script in the description box. Load vector store. It loads a pre-built FAISS index and its matching document into memory, so you can do semantic search without reprocessing PDFs. It reads the FAISS index from the disk, loads the document metadata from the .pkl file. It loads the same embedding model used earlier for creating the index. It ensures the retrieval process works with the same vector space that was used for indexing. Retrieve context. It finds top K relevant chunks from the preloaded documents for a given question. It converts the user's query into an embedding vector. Searches the FAISS index to find the most similar text chunks. Returns the corresponding original text chunks from documents. This step filters the large datasets to find the most relevant context for answering the question. Remove think tags. It cleans up AI model's output by removing any think tags. If you are using any other model that doesn't have the think part, you can comment this line. Generate answer with Ollama. It sends the retrieval context plus user's query to the Ollama DeepSeek model to generate a detailed answer. This is very important part of this script. We are giving a customized prompt to the LLM. In this case, this prompt mostly focus as it was a trained document expert who can answer these hospital related queries. You can tweak this prompt as per your needs. It joins the retrieved text chunks into one string, constructs a structured prompt that tells the AI to use only the given context, and finally returns the generated answer text. It ensures the AI answers are accurate and based on retrieved documents. It reduces hallucination. Get tags. It reads folder names from the uploaded PDFs directory to create a tag list for the selection. It lists all the directories in the uploaded PDFs and returns them as a list. Once we complete the script, upload your PDFs in the PDF uploads directory based on the categories. Here you need to manually copy and paste the PDFs to corresponding folders. After that, run this command to create vector indexes. Now you can see the corresponding vector indexes created in the vector data directory. Now run this command to build the UI with Streamlit. You can see the UI is running in localhost port 8501. Now you can interact with the LLM and it can answer your questions based on the PDFs. So this is a very simple RAG system using DeepSeek. Just upload your PDFs and run the command and it's ready to chat. You can integrate this chatbot in your website or app. You can even build APIs with this that can work with the mobile app as well. The performance and the latency depends on the system's hardware and the model. You can also try with different models as well. You can find the full code in the description box with detailed explanation. So that's all about today's video. If you found this helpful, please consider to subscribe the channel and like the video. Thank you for watching and see you in the next video. Bye.